Good morning, everyone. So, today we're going to discuss the last couple things in our transformation geometry chapter. The first one is the inverse of a transformation, and it's quite simple actually. So, if we have a transformation that maps an object onto its image, then the inverse of this transformation maps the image back onto the object. So, just give you one example, quite simple one. So, let's say this is my frame of reference, right? So my x is x and y. So if I have, let's say, a triangle here, right? And well, we were told that this triangle has been enlarged by a scale factor of 2. So what was the original object? Well, you would basically, if it's taken through the center point 0, 0, you can just assume, well, this is 0, 0, and then you would draw the lines, right, just like we did before. And well, since the scale factor of the original image was 2, I'm looking for the object which was half of its original size. So I would find out what's this length, and I would need to break into 2 equal pieces. Same thing for this one, right? And then this line here as well, and then we would be able to find where our triangle was. And this k here that we're doing now is actually a half. So when we're doing the inverse transformation, our k will be, instead of being an enlargement of scale factor 2, it's going to be a reduction of scale factor half. Now the last topic is combination of transformations. So you might have several transformations happening with your object. Right? So you might have, let's say, a triangle, and then you enlarge, you mirror right through this axis, and then you may mirror through some sort of line. So basically, you're having many transformations happening at the same time. And how would you work with those? Well, the point here is when you're working out your combinations, you're going to represent those combinations, for example, using letters. So you can say, oh, this is transformation H, this is transformation G. So this is a bit more formal than we have been doing before. So let's say that you have a transformation H, which is followed by a transformation G. We would express this as GH. This was the first one, and this is actually the second one. And then we could just, for example, say that this is figure 1, this is figure 2, and we can work how those figures would be. So H will map this figure into figure 1, and then G will map figure 1 into figure 2, and we can work each of those transformations individually. So that's enough talk. Let's look at one example now. So consider a triangle ABC with vertices 2, 1, 4, 1, and 4, 2. So let's draw this. Alright, so we got our axis here now. A, 2, 1, so 2, 1, this is point A. B, 4, 1, and C, 4, 2. So that's our regional triangle. Now suppose R is a reflection in the line y equals negative x, and S is a rotation of 90 degrees clockwise, right? About the center, about 0, 0. Now use triangle ABC to help find a single transformation which is equivalent to RS. So RS, it's a transformation of S and then a transformation of R. So first transformation of S. Transformation of S is a rotation of 90 degrees clockwise. So, and through this center here. So if we flip this, all those points here, here and here. Right, A, B, C. There you go. Now, if we rotate this figure 90 degrees, well, this point 90 degrees, it's going to be here now. So this is our A dash A prime B. Right, if you notice, remember, you're flipping. So here x was 2, now y is negative 2. Y was 1, now y is x is 1. So you've got to remember all of those transformations that we've dealt with before. So this is our first transform triangle. I could call this triangle 1. Okay, and then we've got a reflection on line y equals negative x. So what is this line? Right, you have to. So let's draw this line. Well, it's this one. This is our reflection line. Right, so all of those points, they are going to be mirrored on the other side of that line. So you would measure those distances here and find them on the other side. So how would the final image be? Well, A prime is now going to be here, right? Equidistant to the line. Now B, it was 2 and negative 4, and now it's going to be 1 and negative 4. Now it's going to be 4 and negative 1. Just flip those two. And here our C prime is going to be here now, C prime, C double prime. And we can see that the coordinates, they were 2 and negative 4, and now they are 4 and negative 2. And that's our final triangle. 2. Now what about letter B? So let's see now. So letter B, it's just the orders are reversed. So this is our first one. Now we're first mirroring on the y, on line y equals negative x. So we've got first the reflection and then the rotation. Second comes the rotation. So first we have our line here now. And what would be this if we mirror it? Now, if you want to do the maths, remember this is 2, 1. If this undergoes a reflection on this line, what's going to happen to those coordinates? So we change them, so we swap y for x and we flip the signs. So it should be negative 1 and negative 2. And this should work for all of the points. So B was for 1 and C was for 2. So we should be able to do exactly the same thing. So B prime, this is the first transformation, that's the reflection, right? So B prime would be negative 1 and take away 4, and C prime would be negative 2 and negative 4. So we can plot those points here in our frame of reference. So A prime, negative 1 and negative 2, this is our A prime. B prime, negative 1 and negative 4, and C prime, negative 2 and negative 4. This would be the first transformation, right? So that's this triangle is this triangle mapped through this reflection y equals negative x. Now we have to apply our rotation of 90 degrees. So rotation of 90 degrees, right, clockwise. So it's going to flip it to this quadrant here. And mathematically, what's going to happen? So we've got, let's use this space here. So here, we are going to swap x and y. and our y's will become positive. So our a to prime would be 2 and negative 2 and 1. B would be 4, negative 4 and 1. And C prime, negative 4 and 2. So all of the y's are now positive, and we could plot, we could draw this triangle. It would be here, wouldn't it? Look, A prime is A to double prime is here, B and C. And this is our second transformation. That would be transformation SR. And that's enough for today. And in fact, that's all transformation geometry.